You're welcome once again to Mesoration Mathematics Institute, the home of the transformation of the abstract nature of mathematics into concrete concept. In all our videos, we have been fulfilling our promise by transforming the abstract nature of mathematics using the things we have in our environment as the concrete concept. And in this short video, we'll be looking into the mathematical operators on terms using kilogram of chicken. As a concrete example. In the last video, we made an analysis of terms using the environmental examples, and in this short video, we'll be talking about the mathematical operators on terms. Now we're looking into the mathematical operators. We have said in other videos that mathematical operators are the operators that are used in mathematics because they are tools that are used to solve mathematical problems. And we are referring to a term as the subject of study. We have said a term is a single entity or combination of like entities. This is a term, this is the abstract nature. We are looking into the kilograms of chicken. That is the concrete. This is the abstract. This is the concrete. This is the concrete nature. Because the transformation, this is the transformation. The transformation of the abstract nature of terms into a concrete nature using a kilogram of chicken. That has been the platform of Mesoration Mathematics Institute, and we have said that a term could either be a number 1 up to infinity minus infinity to infinity. In between this we have 1, 2, 3, 4, and you can take also from A to Z. That is the mathematical representation of a term. Likewise, over the kilograms of chicken, we are representing, let's say, a term to be S. This is a term because it's either a number or a variable. So this is 1S, which is the same thing as S. The multiplication of a number with a variable also gives us what we call a term under the operator multiplication. So this is transformed to what? Kilogram of chicken. That means the kilogram of chicken can be transformed as what? S, which is a term. But how can we use the mathematical operators on the term now? We have the basic mathematical operators. That is board. What does this mean? Body mass. We have an acronym of body mass, which is bracket. This is bracket. This bracket of division, multiplication, addition, subtraction. Those are the mathematical operators that are going to be involved in the use with the term. We have, in the complex analysis we did, we discussed the complex tools, which are complex mathematical operators to solve problems, to identify the kind of complex analysis we have. And we are using each of these tools in relationship with the term to transform the abstract nature into a complex nature with the use of the kilograms of chicken. Oh, at this point, sorry, I went to get the dust. Let's apply each of the tools with the concrete and the abstract nature. Let's go for the addition. Addition of terms. We have concluded that we have a term to be a representation of S. This is a 2. Addition is a 2. Over the concrete nature, we have kilograms of what? Chicken. We have the 2 that is very, very important in checking the kilograms of a particular thing. That is the scale. We have the local scale of this one. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's assume this is a scale. A scale is a tool that can be used to measure the number of kilograms a chicken weighs. Now, addition is also the tool that can be used to check what a term is really all about. So, we have concluded that this S is a kilogram of chicken in a concrete way. Let's assume we have example 1, 7S minus 3S. We have made an analysis in the analysis of our terms about something like this. We don't have to repeat the same question. Anybody who wants to check that should please go to the analysis of terms in our videos. So this is 7S, 3S. We have said S has to do with the concrete aspect to be kilogram of chicken. That's that. We have the transformation of this abstract nature to this concrete nature happens to be, we have 7 kilos of chicken. This is 7 kilos. By the time we put it on the scale, this is 7 kilos. 7 kilos of chicken. 7 kilos of chicken. This is addition. We are talking about addition. We have another 3 kilos of chicken. This is another kilos. 1, 2, 3. This is another 3 kilos. From here to here is another 3 kilos of chicken. The total kilograms of this chicken happens to be 10 kilos. That means you already bought 7 kilos. And the visitors just came, said, you're having some visitors, by next week you have to get more kilos of chicken. So you told the seller, give me additional 3 kilos. So by adding 7 kilos to 3 kilos, you are getting 10 kilos of chicken. Looking at these two in the abstract nature, this is 7s. Assuming this is naira s, you have 7 naira, and another person gives you 3 naira. That is 10 naira. This is the same thing as 10s. Let's take another format. This is an house. This is a cow. This is a cow. You have 7 cows in a particular place. And another place, we have 3 cows. The total number of cows in the 2 places has to do with what? The total number of 10 cows. This is related to anything you want to relate it to, depending on what you want to create. Because we have said earlier that is a noun. A term is a noun. And the plural form happens to be the multiple of a singular form. When we are talking about a house, we are talking about houses. We are talking about a term is generally a noun. It could be a place, an object, an animal, everything you around you, a fridge, the printer, the mug, the place, the gas, everything is an object. Everything that has to do with a noun happens to become the property of a term, which is a term. And the multiple of that object is always a term. So let's look into another tool, which is the subtraction. Now looking into the subtraction, let's assume we have 6y minus 4y. Let's assume our y is the same thing as the kilogram of chicken. Let's continue with s for simplicity. So s. This is 6s, 4s. On the scale, let's check the scale now. This is a 2, mathematical 2. This is a 2, a scale, for the measurement of the kilograms of chicken. We have 6s. 6s minus 4s is the same thing as what? 2s. That's the mathematical representation and the mathematical result of the terms. Looking at this, we have 6 kilos. This is 6 kilos. 6 kg. And another one, we have 4 kg. Okay. This 6 kg is the one you bought initially. And your wife came to you and said, we don't have much with us. Oh, we just have let's manage 2 kilos. That means you are taking out 4 kilos from the 6 kilos to get 2 kilos. Let's take another channel. We have 6 kilos. This is 6 kilos. And you check the cash with you. The cash cannot cater to get 6 kilos. And you told the seller, okay, take away 4 kilos from the 6 kilos. Let's go through the chart. 1 kilo, 2 kilo, 3 kilo, this is the 4th kilo. You are taking 4 kilos away from it. So we have 1, 2. You are left with 2 kilos. Because you have taken out 4 kilos from the 6 kilos, you have 2 kilos, depending on the cash we have with you. So that settles that case. Let's look into this another concrete example. We have 6 cars. Let's represent S with cars. This is another car. This is 6 cars in a particular house. In another particular house, we have 4 cars. So in the same house, you are giving out 4 cars out of the 6 cars. As if you are giving this to your workers out of the 6 cars you have in your company. So you have cars that are yet to be given to be 2. From the 6 cars in the company, you have given out 4 cars to the staffs. You are still left with 2 cars to be given. That means the residue of the subtraction happens to be 2 cars. That is another typical concrete example of the subtraction. That's for the subtraction of terms. We have fulfilled the addition, subtraction. Let's go for the multiplication. Now the multiplication of terms. Multiplication of terms. Let's use this here. Well, we have 2. S. This is 2 multiplied by 2s. We have said earlier that s happens to be a concrete aspect of kilograms of chicken. We are talking about these 2s shows us that we have 2 kilos. And this kilo has a multiplication of 2. That means you are multiplying that 2 kilos by 2 in a multiple of 2. That means automatically you are multiplying 2 kilos by 2. That gives us 4 kilos. Because it is a multiple of 2. This is 2. A multiple of 2 again. 2, that is in 3 places. That means 2 in 2 places. That means you're having 2 kilos in 2 places. That gives us 4 kilos. From here, the mathematical representation of this is 2 times 2, that is 4, multiplied by s. Because you have said the term is always a term under the operator multiplication and division. So 4.s equals what? 4s. That is for the multiplication of terms. And also we can try as much as possible to represent this when you go to your shopping mall. Let's assume we have 3 multiplied by y. This, let's use this again. This is s. This s is the kilogram of chicken. By the time you check the shelf, you check for the kilo of the chicken. That is s. You are picking 3 at the shelf. 1, 2, 3. That means you are picking up 3 kilos of chicken. If and only if each of that kilo on the shelf is 1 kilo. We have said the s is the kilogram of chicken. You are picking 3 from the shelf. That means you are picking 3 packs of 3 kilo of chicken. That is for the multiplication. And let's look into the division of times. Division of times. Let's assume we have the same 6s divided by 3. This is the mathematical representation. Let's clean this off so that we'll be able to understand what we're talking about. This is 6s divided by 3. Looking into the concrete aspect, before we come back to the abstract nature, we have 6 kilos, that is 6 kilos. 6 kg. That 6 kg is to be divided into 3. Because you have said, you can't afford to get that. Let's look for 3 people who can share the 6 kilos. So each person has to take 2 kilos. This is 6 kilos. You are sharing it into 3. One person will take 2 kilos, another person 2 kilos, another person is 2 kilos. That means each of the people that are yet to share the kilogram of chicken has to go home with 2 kg each of chicken. So this is now 2 kg of chicken. So this is 6, 1 to 6. This is the first person will take 2, another person, this another person. That is the division into 3. First person, this is the second person, this is the third. We are picking 2, 2, 2, and the total number of kilograms to be shared happens to be what? 6. That is okay, let's look into the abstract nature. This is 6s divided by 3. We have 6 divided by 3, that is 2. Multiplied by s, that is 2s. This is 6, this is 3. We have said the combination of terms under the operator division still happens to become a term. So let's look into this again. We have 6s divided by 3. 6 divided by 3, that happens to be what? 2. The dot stands as a multiplication sign of s. This is 2s. This happens to be 2s. Let's look into the fifth one, that is of. The of terms. When we have something of this form, have half of 6s. This of simply means multiplication. Indirectly. Let's look into the concrete aspect again. We are talking about the scale as a 2. This of is a 2. The scale is the general 2 when it comes to a concrete aspect. So this is 6 kilos. We are talking about 6 kilos. That is now. The half of 6 kilos is 3 kilos. You are dividing, is indirectly that is a technique that shows that you have to divide this on the operator multiplication, which is the same thing as 1 over 2 times 6s, which is the same thing as 6s divided by 2. That simply means you are dividing the kilogram into 2. That is half of 2. Half of 2. When you have a full drink, take half of it. That means you are dividing it into 2. Now, dividing this 6 kilo into 2 gives us what we have of 3 kilos. 1, 2, 3. That is the half of 6 kilos. 1, 2, 3. This happens to be for the first person. This happens to be the second person. That means you are dividing into 2, and each person has to take 3 kilos. When we look into the last one there, that is the brackets. The bracket as a 2. You have 6s, number 6s, the bracket is 2. Let's look into the concrete aspect again. This is 6s. We have assumed that S represents the kilogram of chicken, and 6 happens to be the kilogram, 6 kilos of chicken. The bracket simply means that it is in a confined space, confined domain. This confined domain happens to be within the domain of 6 kilos. You can see it now, we have circled it. Is within the 6 kilos. Now, this 2 is outside the bracket. Multiplying 2 by the 6 kilos tells us that this kilos has an additional of the same 6 kilos. That means 6 kilos in 2 places. Okay, 6 kilos in 2 places happens to be 12. This is 1, 2, 3, 4, 5, 6. This is 12 kilos. Let's look into another instance. We have the first person. This happens to be 2 people. This is a confined environment that has 6s. This 6s happens to be in 2 places, 6s plus 6s. It's the same thing as 2 brackets, open bracket, 6s, close bracket. Because this bracket happens to be a confined domain of a particular time. The extension of that confined domain has to do with the number of times the domain has to open up in the whole general term. So we have 6s, that's the first one. 6s, this is the first, this is the second. If we have this one to be 4, assume we have this one to be 4, you have 6s, which is the third, 6s, which is the fourth. This is not division, we are talking about the fourth term. This is third term, second term, first term. Because you have 6s in 4 places. That is 6s plus 6s plus 6s plus 6s. But the question happens to be 2. We are talking about 6s in 2 places. That is 6s plus 6s. That gives us 12.